Talking about quadratic models. When we're talking about models, quadratic models, we're talking about something that takes on the shape or kind of looks like a quadratic function, the y equals ax squared plus bx plus c. And when we have a quadratic, that means we have a vertex, and that vertex is either the minimum or maximum, right? So it's either the max height or minimum heights. So the most often one that's used of the quadratic models is the distance related to time of a projectile either falling or being shot off or something like that. So talking about distance or height, so S of t, so S of t stands for the height of an object. And it's given by this equation. So you can find the height of the object by using this equation. Negative 16 t squared, which t stands for time, plus v sub 0, which is the initial velocity, so the velocity that you start out, times t, plus s sub 0, which is your initial height. So this is the equation, quadratic model for the height of a projectile, where negative 16 is your feet per second, and v sub 0 is your initial velocity, and s sub 0 is your initial height that you start at, and s sub t is your height of the object at any given time t. So here's an example. We have a ball projected directly upward from initial height of 100 feet with initial velocity of 80 feet per second, and we want to answer these 4 questions. We want to give the function that describes the height of the ball in terms of t. That's just basically asking for us for that function that we just showed. And B is asking after how many seconds will the ball reach its max height. Well, its max height, maximum, that would be the vertex, right? So we're going to have to find the vertex of, or our axis of symmetry, that x value of our vertex, to find out how many seconds will it reach the max height. Then it's asking for what is the max height. That is our y value of our vertex. So we're going to have to plug in that x value into our equation to figure out what our y is, or our s of t. And then C is asking for the interval that gets us 160 feet. So that means we would set 160 feet. That is our height, right? So we'd set our ST as 160, and then we'd solve the equation by doing quadratic formula or factoring or completing square. And then D, after how many seconds will the ball hit the ground? Well, when we hit the ground, what is our height when we hit the ground? It is 0, so we'd plug in 0 for S of t, and then we would solve that equation. So let's go ahead and start with giving the function that describes the height of the ball in terms of t. This is just asking for what is our equation. S of t is equal to negative 16, the gravitational force, right? That's what negative 16 is representing. T squared, and then plus our initial velocity times t, times our time, and then plus our initial height. So as we look at our example from before, we can see that the v sub 0 would be our initial velocity, so that'd be 80, and then our s sub 0, our initial height, would be 100. So then we come back and we can enter those in, and then here's our function in terms of t, right? That's why there's a t in here, because it's in terms of t. So negative 16 t squared plus our initial velocity, which is 80, and then plus, oops, that is an s, and then plus our initial height, which is 100. So there it is. So there's A done. That's our equation. That's what it's basically asking for here. What's the function? This is our function in terms of t, in terms of t. Now we can use this to solve all the B, C, and D. Okay, so here's B. There's our function that we just found. After how many seconds does the ball reach its max height? So that means we have to find our axis of symmetry, right, that x value of the vertex, and we have to find the max height by taking that x value and plugging it in, which x is now t, right? That's our variables, t, not x. So to find the vertex, we can take x is equal to negative b over 2a. Or for our example here, it would be t is equal to negative b over 2a. So here's our b, 80. So I do opposite of that, which would be negative 80 over 2 times our a, which is negative 16. So we have negative 80 over negative 32. And then we can just reduce this. And since this is a kind of a word problem, application problem, we can go ahead and actually not leave it as a fraction, turn it into a decimal. So 2.5, negative over negative is positive. So that would be my max height, or how many seconds. So it would take 2.5 seconds, 2.5 seconds to reach max height. Right, so that answers this problem, right? Now we want to know what is that max height. So now we got to plug this 2.5 in for t and solve. So s of 2.5, this just means s of 2.5 means I'm just plugging in t in for my equation, right, and then solving. So negative 16, I got to take this 2.5 first, square it, and then times by negative 16. Then I'm going to add 80 times 2.5, and then I'm going to add 100. Okay, so I got to take 2.5 and square it, right? So that's basically just, 25 times 25 and then move over the decimal. So 6.25. And then I got to times that by negative 16. And then I'm going to take 80 and I'm times that by 2.5. And I get 200. And then I'm going to add 100. So negative 16 times by 6.25 is negative 100. So I have a negative 100 plus 200 plus 100. That is 200, right? So S of 2.5 is 200, meaning that our max height will be 200, I believe we're in meters, or no, we're in feet, okay? So that's our max height is 200, so that's the answer to B. Okay, so C, there's our equation again that we're going to use, and now we want to find the interval for the time, where on our time, so somehow our graph, here's our function, right? It's a negative, so that means it's facing down, and we want to know, okay, here's our t time. We want to know when does it, at what time, okay, at what time does it reach 160 feet, and then another time it's going to reach 160 feet, right, because it's going to come back down. So what we do, that's our height, and S of t is represented by our height, so we set this equation equal to 160, and then we can use quadratic formula or completing the square or factoring in order to solve this. So first we need to set it equal to 0, so we minus 160 from both sides. And because we're looking at a word problem here, so minus 60 at the end of this, now it's set equal to 0, so now we could do the quadratic formula, because I doubt this is going to factor. We can actually use the quadratic formula here. We can do our negative b over 2a plus or minus, negative b plus or minus the square root of b squared minus 4ac all over 2a. Right, so that equals our x, but for our x is actually t, right? So there's the quadratic formula. So we could use that. We've done before, maybe possibly, I might have shown you how to enter this all in the calculator, and then it kind of does it for you a little bit. So if you know how to do that, that's great, you can do that. Remember, whenever you square your b here, it's always going to be positive, even if your b is a negative or not, right? So this is given our x, which is our t that we need. So we'll just say t, and so it's negative b, so that's negative 80 plus or minus 80 squared. So that's just 8 times 8 is 64. Add 2 zeros. Minus 4 times negative 16 times our negative 60 as our c, and then the whole thing is over 2a, which is negative 16. All right, so here you have a negative, 3 negatives. 1, 2, 3 negatives. That's going to be a negative in here, right? So really I'm going to be taking 6,400 and subtracting whatever 4 times 16 times 60 is. So that is 3840. And I'm going to take 6,400 and minus that. So that is 2560. Then I'm going to square root it, and then I'm going to add a negative 80 to that. And then the last thing I'll do is I'll divide by negative 32. And then, so you're going to have two answers here, because then I'm going to take that square root of that, and then I'm going to subtract, or I'm really going to take negative 80 and subtract that, and then divide by negative 32, because it's plus or minus the square root. Okay, so I'm going to do that, and you can leave that in your calculator. So once you do square root of 2560 on your calculator, just add a negative 80 and then divide by negative 32 and then press enter. And then on this one, do negative 80 minus the square root of that and then divide by negative 32 and get your answer. Okay, so when we do that, we get t is equal to 0.92 seconds and t is approximately 4.08 seconds. So that's where it is in between. So at approximately 0.92 and approximately 4.8, that's going to be our interval. That's where it's above 160, right? So it hits 160 here and 160 here, so then it's above all the way from there to there. So our interval would be from 0.92 to 4.08. Okay. And I guess since it's approximating, you can go ahead and do parentheses is fine. Okay, so the last part here, after how many seconds will the ball hit the ground? Well, what's the height of the ground? Would be 0. And then so we're just basically solving for our x-intercepts, right? These would be our x-intercepts that we're actually trying to find here. So again, it's already set to equal 0, so we could do the quadratic formula. We can divide all of these by 4, right? So we could factor out a 4 from all of them. Make it just a little bit simpler. T plus 5. Then we could try divide both sides by 4, get technical. 0 equals negative 4t squared plus 20t plus 5. So this is not going to be, oops, why did I do a parenthesis there? This is not going to be factorable, of course, so you're going to have to do quadratic formula from here. Okay, and we get our two answers. Here we have a negative 1.04 seconds and a positive 6.04, so of course it's going to be the positive one. What this basically means is, so because you have initial height, you're standing here or standing on something, you shoot it off and it comes down. So that means it's still going to be a parabola back here. So right here would be initial times 0. So that's why you can't have a negative second. So this answer would be somewhere negative, and this one would be our positive 6. So when it hits the ground, it's not going to go backwards, right? So it's going to go forward. So it's going to be our, the time that it takes is approximately 6.04 seconds. That's going to take to hit the ground. Okay, so then here are your homework problems for this example under this section, quadratic models. Go ahead and turn to page 296 and number 53 and go ahead and work on that one. Okay, so if you're having trouble on number 53, you can continue to watch this. So we have lighting, we're doing the projectile again, right? So we have our standard equation for the height of a projectile. Don't do V again, it's S sub 0. Okay, and so we need initial velocity, which it does 200 feet per second. And our initial height, they say, is 50 feet. So there we go. So there's our A. That's our function that describes. So there's A, done. Okay, B asks, determine the time that it reaches max height. And what is its max height? So again, they're looking for velocity, right? So that would be T is equal to our negative B over 2A. That's our that's the time that it takes to get to our initial or our max height. So our negative b would be negative 200 over 2 times a, that would be negative 32. Negative over negative is a positive, then we can start reducing this, but since we're talking about application here, we want actual numbers, so it's probably best not to give a fraction, just to go ahead and give the decimal. So we'll go ahead and divide that, and we get 6.25. So that's your t, how many seconds it takes to get to your max height. Now we want to find the max height. So our max height, we just need to go ahead and plug that in. So we have our t, we're going to plug that into our function s. So we need to square that first. So square that first. And then we're going to times that by negative 16. And then, which is negative 625. Then we're going to add 200 times by our t. So I got to take 6.25 and times that by 200. So that is 1250. Nope, 1250. That's an ugly 50. Let's go ahead and fix that. And then we're going to add our initial height, right, which was 50. So then we're going to add 50. So then we can add all these together. And that is 675. So 675 feet is our max height. Okay, then we go on to C. C is asking for probably an interval of some sort, right? Interval of 300 feet. So we set our height equal to 300. Write our equation, 200 initial velocity and initial height of 50 feet. Go ahead and subtract the 300 from both sides. 300. So then we can use quadratic formula on this, because now it's set equal to 0. Minus 250. So we can go ahead and use quadratic formula on this. So a negative 200 plus or minus the square root. The square root of b squared minus 4 times our a times our c. Again, these are all negatives, right? That's 3 negatives in a row. So that means that you're going to be subtracting there, over 2 times a. Okay, so then we solve this, and this is going to give us our 2 t's, and that will be our interval, and it's probably going to be approximating, right? So you can use parentheses on those. So this one is between t is equal to 1.41 and t is equal to 11.09. So it's going to be in between those. So 1.14 to 11.09, and so that's our interval, that it's going to be above 300 feet. And then the last one, when will it hit the ground? So set it equal to 0. So that was C. D, set it equal to 0. Again, you can use quadratic formula, or complete. You don't want to do complete and square, just use quadratic formula, because it's probably not factorable. And plus 50 is our initial height. So here we go ahead and just use quadratic formula. Here we have, hey, you can divide all these by 2. So you can divide all of them by 2. So if we divide all of them by 2, we get negative 8t squared plus 100 t plus 25. And so then they're smaller numbers for you. So then when you do your negative b, you'd only have negative 100, and then you're squaring 100 plus or minus the square root of 100 squared minus 4ac. So this time our c is positive, right? So then we have a negative times a negative. So here we're going to be adding to whatever our 100 squared is, and then square rooting that, and then adding negative 100, and then dividing by negative 32. and then taking that same thing but then subtracting the -100 and divided by -32. So these two answers, one's probably going to be negative, right? Because you do have an initial height, so that means one's probably going to be negative, and then the other one's probably going to be positive, so that would be your answer to D. So it's approximately, the positive one is 12.75 seconds. So there's your answer to D.